Hi everyone, how are you? So we are again here in the Facebook Live with Ubidots. Today we have Jose, that is our hardware engineer, and we have again with us Agustin, who is our CEO and co-founder. So today we're gonna talk about data security for IoT. And Jose, can you tell us a little bit more?
Yeah, sure. Today we are going to talk about data security from a hardware side. How should you improve your data security management, and how should you code? We are going to look some code in C using an expressive device, and what are the difference between HTTP and HTTPS, and what are the main difference in data security using one or the other one.
Yeah, this is a very important topic. The reason Jose is joining us today is because he is the hardware engineer in Ubidots. As you are already aware of, we are a software company, but that doesn't mean we don't need hardware engineers, because ultimately we work exactly at the edge between hardware and software. And we have a running joke all the time here in our office where we say that the software developers, they don't understand us, and I include myself because I'm also an electrical engineer, and that is because a lot of the things that work in the software world don't necessarily work in the hardware world. And to give you a very brief example regarding security, of course, every day we access the web through our web browsers. So we use Firefox, Chrome, etc. And these web browsers, they use certificates to authenticate to servers. So it's a client-server architecture to exchange data in the form of websites and pictures and videos and everything we consume. Now, you may wonder what happens in the back. Jose is going to explain us a little bit about that. But this is a fairly easy task to do for a computer, because it's a machine, it's built for that. It doesn't have limited resources. So the management of encryption, which is a computing intensive task, is of course done by your browser every day, and we don't even notice that. Now when you go to a hardware device such as the one that Jose is going to be using today, the resources are more limited. Not all the manufacturers offer off-the-shelf libraries to manage security, so then it becomes something worth looking at, and that's exactly what we wanted to do today. Just give a brief example of how you can manage IoT security using Wi-Fi. So cool. On to that. Jose, please.
Okay. So I would like to start with some background about what HTTP and HTTPS are. So I'm going just to switch to an already slide that I have prepared for this presentation. Give me a second, please. So, okay, so basically what's the main purpose for data security? So there are two main purposes. The first one is data privacy. Who can access my data? Right now it's very important to know who can access to my data, the data that I'm sending from my devices. So anyone in the network should have access to my data, because I can be managing sensible data. So it's important to avoid that a person in the network can access to my data, the data that I'm sending to the cloud. And also data integrity. So data integrity is related with that the data that I'm sending from my device is received by the receptor properly. But today I just want to talk about data privacy. So how can I avoid that a hacker or anyone in my network can access to the data that I'm managing? So that to make sure my business, my data business is secure. That's the main purpose of this presentation. So first I want to talk about HTTP and HTTPS. HTTP is the most popular protocol for sending data in the cloud. Why? Because it's already a standard. Most browsers use them. So when you surf in the internet, you are using HTTP. So it's a well-defined web standard, and also most of the devices in the market supports that. So that's because of this, it's very important to to talk about HTTP. Yeah, HTTP is based on TCP. TCP is basically a communication protocol. It's the heart of the actual cloud data exchange. So most of hardware devices supports this protocol. There are also another protocol like UDP, MQTT, and so on. But the heart of all of them is TCP. So most devices, including Expressive, Arduino, and the popular development boards, supports this protocol. But HTTP has a big issue. It's not an issue itself. I think that in the beginnings, HTTP was made for easy communications, but in fact it's a plain text format. So when you use a protocol that sends data in plain text, anyone in the network can sniff your network, your packets, and see what are you sending to the cloud. That's the main issue of the plain text format. So after the creation of HTTP, it was created HTTPS. The S is because secure, so it means that an additional layer is added to the HTTP protocol, and this layer let us to send the data encrypted. In that way, anyone can see what are we sending to the cloud. So that's the main difference between one and the other one. Okay. So what happens when you use HTTP and when you use HTTPS? Usually we have to send to the cloud passwords for data change. If you use HTTP, you can see that you just send plain text. So you say to the server, hi there, this is my password, and you are sending your password. So this is a sensible data, sensible information, and this should not be seen by anyone in the network. When you use HTTP, the same password is encrypted, so you just see a lot of garbage or something like that, encrypted characters. But in fact, the protocol is the same. It's HTTP. You only add an additional security layer. So basically, what does HTTPS need? First, you need the Ubidots Pen certificate. You can download it from our official docs. And you also need a device that supports TLS 1.2. TLS is an encryption protocol, an encryption algorithm, and this your device should support at least RSA. There are a lot of kind of algorithms to encrypt data. One of them is RSA. There are another that ESCC and so on, but unless it should support RSA, and most devices in the market already support that. So it's not difficult or it's not hard to implement this kind of security in your devices. So what are the basic HTTPS steps for sending, how an HTTPS socket is implemented? So first the device opens a socket, a TCP socket with the server. Then the server answers to the device a certificate. The device also has stored a certificate. So there are two certificates, one that comes from the server and one that comes from the one that is stored already in the device. And using some kind of cipher methods, those certificates are valid. If the device does not valid the server certificate, it assumes that the server is not the one that, like he's saying, that is. So in example, if you send data to Ubidots and the server answers with a wrong certificate, you are not sure that you are sending data to Ubidots, so you just avoid to send data to there. And then once you check your certificate, you begin a secure connection using HTTPS. But let's see a demo, so you can see what's going on in the background when you send data using secure protocols. So here I have an Arduino code. Basically, I'm using an expressive device, and this is a typical way to send data to our broker, to our endpoint, to Ubidots. Look that I'm using our official endpoint, and I'm using an unsecure port, which is the 80. Then there is a routine for sending data, nothing very special. In this case, I'm just sending fixed values for temperature. But look into this. The server that I'm using is the official one from Ubidots, but I'm using port 80, and I'm using HTTP. So if I use this kind of communication, I would also sniff, or anyone in the network would sniff and see what I'm sending to the cloud. There are another way to send those data, which is this one. Expressive already supports that. Expressive already supports HTTPS. The only that I have to change is first the port that I'm using. You can see that I'm using the same endpoint, industrial.api.ubidots.com, but I'm using another port. This port is the secure port for all the Ubidots server, and I'm also making a check. I'm checking the certificate offered by Ubidots.
Let's say a quick question arise. I know some of our users might be wondering, since we support both HTTP and MQTT, how does it work with MQTT? Or
okay,
maybe we can cover this on a later Facebook Live, or
no?
How would it
okay.
work with
I'm just
MQTT?
going to refer to our docs. Give me a second. In fact, HTTP and MQTT uses TCP in the background. So
Okay.
HTTP uses the port 80, but MQTT uses another port. So in our docs, it's specified which port is for MQTT. This is an unsecure port, the 1883, but there is also a secure port, which is the 8883.
Okay.
Yeah.
Awesome.
So also here in our docs, you can download the certificate for also not only for HTTPS but MQTT using TLS. And in fact, in the background, the way to implement the socket is the same. So you just the server just exposes to you a certificate using this pen certificate already stored in your device. You can match them and look if the server is real, and then just begin to send data. So the main change between MQTT and HTTP are the way that they send the packets, the way that they encrypt and send the packets. But in fact, it's TCP. In the heart of these protocols is TCP.
Cool. Thanks.
So basically it's the same code. Then I make a small verification of the server. Sorry, I have not switched to the window with the Arduino code. So basically it's the same code. I just make a certificate verification in this line, and if the server is verified, so it means that the server is Ubidots right now in the cloud, the server which I'm going to send data. If the server is verified, then just I begin my routine to send data. So there are the change is very small, but what I win with this change is a lot, because with this small script, all my data will be encrypted, and that's what I'm going to show you right now. So here is Wireshark. Wireshark is a very popular software for security purposes. And here I'm just listening what is going on from my network. So I can listen to every packet inside our actual network. So I'm just going to make a small sniff to this IP. Give me a second, please. It's thinking. It's in that.
Too much traffic in the network, probably.
So I'm going just to reboot the connection. Give me a second, please. So yeah, basically, I'm just making a follow to the TCP trace of that IP, and look to this. This IP, which belongs to an expressive device that is using TLS. You can see that all the characters are just garbage. They are encrypted. You can only see some random characters, but you don't know what I'm sending. You don't know anything about what my device is sending to the network. So any attacker, even if it's not on the network, maybe an attacker can be in the WAN, not in your LAN, but in the WAN, would see this. So if someone tries to see what are you sending, he will see just random characters. So that's what we win using TLS. And that's the main advantage of implementing this kind of security, because if you are thinking in a business application, you should think also in security, in data security. But just let's see another device that is sending data in another way, so in a not secure way. So if you send data in a not secure way, meanwhile it loads, I will see not only but the token, I will see also my temperature reading. So maybe you are just reading temperature, but you can be sending to Ubidots or to anyone, to anywhere in the cloud, any kind of data. So anyone would see that. So just look here. This IP is the one that belongs to the device that is sending data in an unsecure way. So let's see what the Wireshark sees. So remember that HTTP is a plain text format way to send data. So let's wait a moment and look here. I'm not seeing random characters. I'm seeing all the socket, all the characters that I'm sending from the device. So it's exposing not only your token, your Ubidots token, but it also exposes what are you reading, what are you sending, what is your payload, what are you sending to the cloud. So this is a critical application. If you are developing or implementing a critical application, this should not happen. So that's the main advantage of implementing this kind of security in your devices.
Jose, I have an anecdote from an actual customer that is a publicly traded company down here in Latin America, and the reason they implemented security, of course, first is because it's a best practice, but also because they were worried about a third party knowing where specific cargoes were going, and therefore no sensitive information about how to trade based on how they move things around the country. So it's very sensitive to know the data. It's not only about being exposed to have remote control. It's not only about being worried about somebody turning your home lights on and off without your permission.
Yeah.
It's also about people actually knowing what thousands of devices are reading and maybe making bad decisions based on that data.
Yeah.
Jose, we have a question from Roberto, and he asked us, I have a cellular device, particle Electron. How do you recommend handling security and encryption in it?
Okay, particle is a very special device because if you have a particle Electron, they don't have implemented TLS, but they also have implemented their own way to encrypt data. So I made a test in the past when I was developing the particle library, and I made a sniff by myself. And even if I was using the classic unsecured client for TCP, all the data that came from the particle Electron was encrypted. So it's a very nice work from the guy from Particle, because by default they send their data using a particle electrode. They send the data encrypted. And if you are using a particle photon, their TCP client is already unsecure, but you will also use particle webhooks. And particle webhooks already support HTTPS. So if you are thinking in a production or an industrial application, you should go with particle webhooks. To implement all of this, you don't need to code anything like I just showed you. They already did that for you. So
Perfect. Then we have a second question coming, and it's what's the difference in security handling among Wi-Fi, cellular, or LPWAN?
okay. It's different because I was talking just about layer transport security. So this question is about how you send your data, the way that you send your data, the protocol. So LoRaWAN is it's totally different from HTTPS. LoRaWAN begins to use HTTPS once the packet received in the antenna. Okay. Yeah. So the packet between the antenna and the device is already encrypted, but they follow another guides from LoRaWAN, another guide for security.
It's a lower level. So the encryption, like one would have to decrypt like a radio frequency wave in order to understand the content. Because it's like on a different level of the stack.
It's a different way to encrypt data that is already encrypted, because if you use LoRa, the data is already encrypted. And if you use Wi-Fi or GPRS, you are also use HTTPS, but you also can use HTTP. Both of them are different. The difference between them is that for GPRS you need a cellular network, and that's the way that you send your data, but the protocol that you use is the same, HTTP or HTTPS.
I'm going to open a discussion there because I've seen mixed opinions amongst our customers. Some of them say, you know what, first thing, what I'm using is not extremely sensitive, and second, it's using cellular. So the nature of the cellular is that the packets leave, that they go to your cellular operator, they get mixed, with different sources, and then they reach a final destination, and then that final destination doesn't have a way to track back to the actual device that sent the data. So they argue that Wi-Fi, yes, you can sniff a router, you can go somewhere and sniff a router, but with cellular, it is going into a private and secure network that belongs to your mobile operator, and therefore they're not too worried about security. I mean, at least like a man-in-the-middle attack. What would be your 2 cents for this?
I think that the example that we are seeing here is sniffing a local network, but a person that wants your data can be in your cellular provider, can be in the server that receives your data. It can be anywhere. So if you just use HTTPS, you can be sure that even if it's on your cellular provider, or if in the server side, or in any of the routers that receive your data, because remember that there are a lot of routers that receive your data once your packet comes out to the WAN. So anyone in all the path between the device and the cloud, the receptor, would not see what are you sending. We'll see just random characters, even if it's on the cellular provider side, or even if it's in the server, or even if it's a sniffing just like we did here. They just see random characters. They cannot access to your data.
Okay, and there's a guy, Rafael, that asked us, did you work electric imp models?
Yeah, we in fact we have a library for electric imp modules. Electric imp also supports data security, so it's a cool device also.
Perfect. And sorry.
No, just want to add one thing. We, as you might be aware of, we support both sending the token in your URL or in your HTTP headers. Doing this research, we've seen that some routers, they log the URLs. So not every router in the world logs the content of the packets, because it will be infinite, but some of them do log from where it's going and from where it comes, which means the URL is exposed. So you want to send the token within the header of the HTTP and not in the URL, also as a good security practice.
Also using a post. So some guys just make same data using a GET request, but the proper way, if you are tinkering in security, is using a post instead of a GET request.
Yep.
Okay, we have other questions. David is asking, how heavy are the certificates to store within the devices?
Okay, that's a good question. In fact, in the past, to load a certificate, you need a device with a lot of tons of memory. But I would like to show you just how much memory does this certificate uses in my custom script. So right now the device, the certificate length tends to be lower. So but we can make a lot of application using the length of the actual length of the certificate. So they are a lot of bytes also, yes, but the penalty is you load more bytes to your device, but you win in security. So it's a trade-off. What do you prefer? For me, it's better to spend some more bytes rather than make my data not secure. So look here. In fact, here I have two certificates here in this device, and it only takes 31% of the total memory of the device. So you have almost 70% of memory to your firmware routine. So I think that's enough for most of application for most of IoT applications. So it's a very good question.
Okay, and we have another one coming from Jose Luis, and is it possible Arduino Uno work with HTTPS or HTTP only? Okay,
in fact I was looking into Arduino. Arduino does not have a native way to use TLS, unfortunately. So the guys from Expressive made a wrapper from a public C library for TLS, and that's why we can use TLS using an Expressive device. Here all the tests were made using an Expressive device. But unfortunately Arduino right now, or less, I don't know that they support HTTPS.
Yeah, I think, side note, like these little guys, they have everything an Arduino Uno has with Wi-Fi. So if you have an Arduino Uno, you still have to buy a Wi-Fi shield, so that's going to be extra cost. And we all love Arduino, of course. We're using Arduino IDE, but we've just found these little Node MCUs which have the Expressive chip to be very affordable, great for prototyping, and as Jose said, the guys from Expressive did a great job by porting a lot of libraries that can even make it to production. So just a quick note for Jose Luis.
Perfect. I think
Do you guys
We have
any additional questions?
no yet. I guess that could be then all for today, probably.
Cool.
Do you want to add anything, Agus or Jose?
Well, no, I want to thank Jose for backing me in this request of making hardware development easier from the IoT standpoint, and that includes, being able to have TLS and SSL libraries in devices. If you have any device that you want to work with and you're not sure how to handle security from it, please feel free to reach out, and we'll do our best to respond, and maybe even have a second Facebook Live with this new device.
Cool.
Okay. So thank you everyone. Remember that you can tell us if you have any topic that you want to talk during this Ubidots Live. And okay, see you in 2 weeks.
Bye bye.
Cool. Bye.
Bye.
Guys. Ciao.